Hello everyone, I'm Bart Massey. Welcome as always to Introduction to Programming. Today I want to talk a little bit about command line stuff and about standard input, output, and error, which are some special files which are really handy in dealing with command line stuff. So let's take a shot at that. Every operating system, Mac, Windows, Linux, every operating system you're likely to work with has some way to type commands and run programs. This is, so that instead of having a graphical user interface, you can interact with a text user interface. That interface, the so-called command line, is an absolute necessary feature for programmers like yourselves. And Linux and Mac have a thing called a terminal emulator that you can open. You can get a terminal and you can type at the terminal. On Windows, you can do a thing called, you can open the run program window and type CMD at it, and running that command application will give you a command line you can work with. It's super easy to build Python tools to work well with the command line. Let's look at a little bit of stuff that the command line lets us do. So here I can ask, where in the file system, where in the structure of folders and directories am I right now? I'm sitting in a place called, a folder called home, in a subfolder called Bart work, CS161 code, finally in a subfolder called examples. And if I look with ls in Linux, in DOS it's dir. You can in Windows it's dir. You can find out what files and directories, subfolders are sitting here, and I can do things with those. I can do things like copy one of those files to the screen. I can run commands on them. So if I want to edit one of these files with my favorite editor, I can type, which is not Moo, but is called Emacs. I can type at that, and then I'm interacting with the thing. I can also do things like run little teeny commands. On Linux and Mac, there's a command called WC, which counts the number of lines, words, and characters in a file. So I can say doesn't really matter, /etc motd is a file. If I look at it by using the more command, I can see that it's a file that contains the message that's typed, the message of the day, the file that's typed at system startup. I can also find out how many lines, words, and characters. That says 7 lines, 40 words, 286 characters in that file there. I can pipe the output of one program into another, so I can do things like find out how many blank lines there are. I can egrep this pattern. This is match every blank line. I'm going to use less than because reasons I want to talk about in a second. Looks like there might be 2 of them. I'll use word count in lines mode, and it says, yeah, there's 2 lines. So this takes the output of this command, this mysterious looking command. The input of that command is read from this file, from etc motd. That's what the less than means. It's going to be then, the command's going to be run, and the output of that command is going to be passed to the word count command, and it's going to print to us what's going on. I could write that output into a file as well. And now the file /temp/count. So the point is, these programs, these commands in Linux or in Mac or in Windows have an idea of what their input is and what their output is. And that's really useful because it means I can make them take input from any place, right? I can do things like this. And now by default, if I don't tell it where to come from, standard input comes from me. And when I hit Control D, which is the Linux and Mac way of saying this file is, I'm done typing, then it says, oh, look, that's a file, it's 2 lines. So how does that work? What's the magic here? There's some really weird magic going on, and that's what I want to talk about today. The magic here is the simple magic of things called standard input, standard output, and standard error, which are sort of 3 files that are provided to the program when it starts up. We talked about files, and now these are special files in the sense that we don't know where these are. We don't open them ourselves. It's just when our program starts up, when our Python program starts up, it has file values for the file where input should be read from, the file where output should be written to, and where error messages should be sent. And you may have noticed that sometimes those files aren't, you know, on storage at all. It might be that standard input is a file representing the user will type this, right? Standard output may be to the screen. Those, it turns out, can be represented as files as well, and we don't really have to care. We just can you know, we can redirect, we can pipe, we can do all this stuff. And this idea of standard input, standard output, and error, you know, the files that are there are in the module called sys. There's the file standard in, which represents where input's coming from, standard out, which represents where output should go, and standard error, which is the file that you can you should write error messages to, so that even if there's pipes or redirection or whatever, the user, usually that's connected to the user's terminal, and they'll see the error messages on the terminal. We won't talk so much about standard error today, but you should be aware it exists. All this is really abstract and probably a little confusing, so let's just look at an example. I'm going to count the number of lines. I'm going to do what word count minus L does, right? I'm going to count the number of lines of text on standard input. The way I'm going to do that is I'm going to import sys, which contains standard in and standard out. I'm going to set my count to 0 because I haven't read any lines yet. And each time I read a new line from sys.standardin, remember when we use for loops with files, with text files, it reads a line at a time. And we're going to ignore what we read. We're just going to add 1 to our counter. So after I've read the first line, the count will be 1. After I've read the second line, the count will be 1 plus 1 is 2. After I've read the third line, the count will be, 2 plus 1 is 3, and so forth. And we'll keep going like that until, remember, when we're out of lines of text in a file, then the for loop exits. And then we can print to standard out that count. Now notice that I could have just said print count. There's absolutely nothing special. The default, if you don't say a file to print, we talked recently about giving a file to print to. If you don't give any file, then inside print it treats it just like I had said. File is standard out. And so here we are. We read, we write, blah, 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 blah. So now I've got this command that should work just fine for this stuff. Let's go back to our command line and look at our thing. There's our line count program sitting here on disk because I saved it. And let's try it. It should be 7, I think. Whoops, no file name, less than file name. It reads as its input that, but of course if I do this, so we've written our own little line count program, right? And we could absolutely extend that to be a program that counted words and characters as well with a little more work. And I can use this just like I can use WC. I could, for example, do the blank line thing I did before. And now the egrep command runs and spits out just the blank lines, and then our line count program counts them. And if we look at this file, sure enough, there are 2 blank lines in it, just like it said. So we can literally write our own little utilities that work with standard input, output, and error in Python, and everything's good. You know, I can write programs that do other things. If I want to translate a file to all uppercase, for example, I'm just going to edit this a little bit, not very much. I don't know why I'd want to do this, but if I wanted to do it, it wouldn't be much different than the program I have. This time I actually do care about what each line is. I can just print the uppercase version of that line, and there I am, just translating the file to uppercase. Notice that as it reads each line, it prints the uppercase output, which makes things a little confusing. It doesn't wait till the end. And there we are. Oh, and notice we're getting an extra blank line everywhere. Why are we getting an extra blank line everywhere? Because there's a new line on the end of this when we read it in. So print is putting a new line, the new line that was in the string. It's also printing its own new line. So let's get that out of there. There we go. That looks more likely. And there we go. That's how we convert that's a way to convert the thing to uppercase. Notice what we don't have to do here. We don't have to specify what file we're reading. We don't have to do any of that stuff. All that stuff is just handled. This works, you know, along with other programs. If I do ls, which prints the current thing, there's my ls output in all uppercase. Ls actually works differently if you pipe its output to a program. Some people consider that a bug. But when we pipe it to our program, it translates everything to uppercase, just in case I wanted that for some reason. So that's standard input, standard output, and standard error. And it gives you a little idea of the power of the command line. Notice that we can do things with a little bit of command line programming that would take a lot of messing around with mouse clicks and dragging and opening and closing windows to do if you could figure out how to do them at all with a more traditional GUI. And that's why the command line survives to this day. You'll want to get comfortable with the command line. You're going to be using it throughout all your programming pretty extensively. And so trying it out is a good thing. Mu is nice to get started, but at some point you might want to start messing with the command line. You may even want to use an editor like Vim, to edit your program. This is what a lot of people use in editing their programs, and I think Carla will ask you to learn to use that at some point. Someone will ask you to learn to use that at one point in later courses. You might want to get started now. It's a real pain in the neck to learn. Once you've learned it, it's actually pretty neat. Yeah, that's what I had to tell you today. I think things are good. I mean, you got to understand that this, you know, this standard IO, as they call it, standard input, output, and error, is super common. It's great not to have to mess with opening and closing files. It's great for the user to have control of where the input's coming from and where the output's going. And it's great to chain programs together with pipes. So yeah. Stay safe and well out there in these very difficult times. I know it's tough. Thanks for listening, and I look forward to talking to you again soon.